Welcome to the very last voice lecture for our statistics class. This is chapter 13 lecture, Inferential Stats in Healthcare. Inferential statistics, that allows us to generalize from a sample to a population with a certain amount of confidence in regards to our findings. Without inferential stats, it would be very difficult, short of conducting a census, to really describe the characteristics of a population. The ability to interpret inferential statistics requires a pre-existing understanding of descriptive statistical measures and computations, many of which we will be covering throughout this lecture. When we're trying to determine the characteristics of a population, the mean from one sample may not be sufficient because of random sampling error. Really, a more accurate representation could be found by taking many large samples, calculating the mean for each sample, and then finding the standard deviation of all the sample means. This value would then be called the standard error of the mean, and it's abbreviated SEM, and comes from the standard deviation of many sample means. The confidence interval is a range of scores in which we are estimating the population mean to be. It lets us know with a certain amount of confidence where the mean will lie. The larger the sample, the more confidence there is in the mean and the smaller chance for a sampling error. The null hypothesis states that the difference between two population means is 0. This statement is generally made based on two sample means. For example, let's suppose we obtain a sample of the heights of 15-year-old girls at a high school A, and a second sample of the same thing, heights of 15-year-old girls at sample B. We may find in that case that at high school A, girls appear taller than at high school B. Because there's always a chance that the null hypothesis is true, testing it will lead to a probability that it is true. The smaller the p value or the probability, the more evidence that we should reject the null hypotheses. As a rule of thumb accepted by most statisticians in hypothesis testing, if the probability that the null is true is 5% or less, then the null is rejected. Dealing with levels of uncertainty in hypothesis testing creates two types of errors. The lower the percentage that the null hypothesis is true, the more significant the finding is. Most research is carried out to reject the null. The type 1 error occurs when the null hypothesis is rejected, yet it is actually true. And a type 2 error occurs when the null hypothesis is not rejected, yet it is false. And your book in the chapter does go through some examples of each type of error that you should read through. A t-test is an example of a test of the null hypothesis to determine if a set of results is statistically significant. In order for the results to be considered statistically significant, the probability of the null hypothesis is true should be 5% or less. Although those t-tests are used to test the difference between two means and analysis of variance or ANOVA, Test is used to test differences among more than two means. Sometimes ANOVA is referred to as an F test, F as in Frank. The chi test, or chi square, is a test of significance that deals with nominal data, specifically data where the standard deviation and mean are not meaningful descriptions. And again, your textbook reading and exercises do have some examples of this test as well.